This is our presentation on CRISPR-Cas9, the editing of genes. I'm Antoinette.
I'm Elijah.
And I'm Gurjot.
We'll be going over CRISPR and how it works, our model of it, the disease we picked, and its effects on its community, as well as the negative effects of it. Introduction to CRISPR. Simply put, CRISPR-Cas9 is a gene editing tool that can be used to edit DNA. It can do this by removing, adding, or altering sections of DNA in a sequence. Going a little more in depth, scientists will make a strand of RNA with a Cas enzyme attached. This is called the guide RNA. This RNA leads an enzyme to the site where the cut is needed. After, they remove, modify, or completely delete it, and leave the cell to join the DNA together again. This process effectively changes the gene and is used to either turn a gene on and off or modify a faulty gene.
And this is our model. Tay-Sachs is a monogenetic disease caused by a mutation in the hexagene, which codes for the hexosaminidase, which is an enzyme that breaks down the ganglioside buildup in your brain and nervous system. This buildup can lead to harmful effects like muscle weakness, difficulty speaking, seizures, hearing loss, and vision loss. Tay-Sachs happens to disproportionately affect Ashkenazi Jews, French Canadians, and those of Cajun descent. Although these communities have been able to lessen the effects of this disease through gene testing efforts, they are still highly affected. We don't particularly identify with these groups except for one of us being half Cajun descent, but we picked this disease because of its effect on children. This disease is usually infantile onset, with the patients dying within 4 years, leaving these communities with less viable children to grow and excel in their communities.
Where the DNA will be cut. Tay-Sachs is caused by a mutation in the hexagene, which is located on chromosome 15. This mutation is either a deletion, point mutation, or frameshift mutation. To remedy this mutation, we would find a mutation and fix it, or add the part of the gene that is missing. Negative effects. There could be negative effects of these, including overall wariness of this technology because of past events with racism and eugenics. They could never have full confidence in their doctors, and if a doctor were to actually change something other than that specific gene, it could lead to even more mistrust in minority communities toward medical institutes. Many of these communities might also have a limited availability to gene therapy due to finances. This could create a bigger disparity between the rich and the poor, because the rich will be able to fix their babies' genes, letting them live longer and have full lives, while the poor will not, forcing their children to die early and actively pushing them down.
Thank you for listening to our presentation on CRISPR-Cas9.